Hi there. In this video, we're going to talk about finding percentiles, and they're also called cutoff values. Okay, so what does this mean? For any percentage of data, there's a corresponding percentile or cutoff value or cutoff score. Okay, so for example, this in the image here, we've got a normal curve with 70% to the left and 30% to the right. That line that's dividing the two, that is the score. That's the percentile or the cutoff score. So we would need to have a scale here, right? But whatever that value is, that would be the 70th percentile. Okay, so it's the value that leaves the given percentage of data before it or below it. Okay, so we may be given a percentage and need to find the cutoff value or cut score as well. Like, what's the cutoff for the top 10%? Or what's the cutoff for the top 40%? Anything like that, okay? So notice a percentile, when we use that ending on percentile, that's a value. It's not a percentage, okay? But it has a percentage in it. So like we would say, this score right here is the 70th percentile. So we're using this, the percentage 70%, but the actual percentile is the value that cuts off the bottom 70% from the top 30%. Okay, and percentiles are always below. So if you're looking for a percentile, you're always putting that area into the left. Okay, now, as you can imagine, there's an app for that. So we're going to keep using Staplet. And this is the opposite one that I was talking about before. So let's go right over to Staplet. Okay, this is from a previous video. So the operation at the very top, there's two options, right? So far we've only used calculate an area. So remember, an area is a probability. But if we want to calculate a value corresponding to an area, that's called the inverse. So it's also called the inverse normal. You might see that in some apps or some books or contexts. Okay, so, and that's why I wrote it on the notes right here. I wrote inverse normal right here. Okay, in case you need that. Okay, we're still using the regular normal applet because this one does both. Sometimes there's two separate ones. That's why I like Staplet, because they have them both together in one. And then you just decide which one to use rather than having to decide which app to use. Okay, so in the Staplet normal calculator, we're going to set the operation menu to calculate a value corresponding to an area. And then it's really similar to what we've been doing. So let's do an example. How about that? Explain by example, and we'll come back to the instructions here. Okay, so let's continue the rainfall example where the mean annual rainfall of Portland is 40 inches with a standard deviation of 8 inches. Okay, so I'm just going to write my model again. X is normal, 40, 8, so I know what model I'm using, even though we've used it before. Okay, and then it says shade and find the cutoff values for, and this says the lowest 10% of rainfall. Okay, so what's the driest 10% of years? Okay, so I don't know. I'm not going to mark. I don't know exactly where 10% falls, so I'm going to look at the picture first. But I do know that 40 is in the middle. Okay, so let's go ahead and put in our model, 40, 8. So 40 goes in for the mean, 8 goes in for the standard deviation. And then now it's going to ask me different questions, right? Because I'm doing the inverse. So now it's asking me if I want to calculate a boundary value. So that's another way of saying cutoff score, percentile, boundary value. That's another way of stating it. For a left tail, a right tail, or central. Okay, so lowest 10%, that's going to be left tail. That's the bottom 10% or the driest 10% of years. And 10% is the area, because we've seen percentage, area mean the same thing. Okay, when I hit calculate values, use the picture as a check, right? If I saw something on the right, it'd be like, wait, no, I did something wrong. So use that as a double check. Okay, and now I can see that it's just a little below the 32. And the z-score is negative 1.2. So I could go 1.2 to know exactly where to draw that. I go 1.2, almost 1.3 standard deviations below the mean. And then the value of that is 29.7476 inches. Okay, so I'm going to draw that while I've got this on my screen, and then I'll show you the notes. So about 1 1/3 over, and then I'm going to shade that, and that is 29.7476. Okay, so here's what I wrote. I put the 29, and I've actually got a screenshot for you right here, and for me, so if I would have used it. So 29.7476 inches. The thing about cutoff scores is their values, right? So we always want to have the units on there. That's the value that separates the lowest 10% of rainfall. So the driest 10% years for rainfall had 29.7, you could probably just round it to 29.7 inches. Excuse me. Or less. Let me pause it. Okay, I'm back. I've been talking a lot today. This is my last video for the day. Okay, so 29.74 inches. So if I was going to write that in a sentence, I would say the lowest 10% of rainfall. Actually, I think it'd be easier just to write it in percentages. The lowest 10% of rainfall. Yeah, I don't like that one. The 10th percentile for rainfall in Portland is 29.7 inches. Okay, so that means 10% of the time, the driest 10% of the time was 29.7 or less. Okay, two more. We've got the highest 5%. So this would correspond to the 95th percentile, right? Because percentile is always to the left or below. So 5% above corresponds to 95% below, since the area has to be 100%. Okay, so let's go ahead and put this in Staplet. This will be a right tail of 0.05. Oh, and I can click on Show Labels on Plot as well. Okay, so I get 53.1588. Now notice I could also do left tail and 0.95. It's the same value in between there, right? It's the cutoff line. So you can do it either way. If you have a preference, I was on left tail before, so I could keep it left tail. I want to shade it to the right, so I'm gonna do right, but the number is the same either way. Okay, so on this one, it is, the z-score is 1.6449, so I'm gonna go 1.6. And this value is 53.1588. Okay, so the highest, the years, let me try to do that one again. The years with the highest 5% of rainfall. I think I was missing the years, which are the cases, and so that was made it tricky. The years with the highest 5% of rainfall got or get 53.2, I'm going to round it, inches or more. Okay, I'm saying or more because they could have gotten more, but the cutoff is actually 53.2 inches, right? The actual, so the 95th percentile is 53.2 inches. We wouldn't say or more for that one because the percentile is the cutoff score. Okay, one more. Sometimes you'll have a middle, or as the app calls it, central. The amounts of rainfall that define the middle 50%. Okay, so now we're going to go to what Staplett calls central, and if it's 50%, that's 0.50. And got to make sure it definitely looks centered, so that's important because the middle 50% should be centered. We could have 50% shifted anywhere along there, right? But this definitely looks centered. So the middle 50% years of rainfall are between 34. Oh, here's that between. I knew they did it somewhere. Here's the between notation, but it's maybe not useful to you in this place. You could write your answer out like that, or you could write it out in words. I'll write it both ways. So it's between 34.6. I'm going to round because we wouldn't measure rainfall probably that accurately. 34.6 to 45.4 inches. And then I'm going to look, the z-score negative 0.6, so that's about right there. And then positive, oh, this is actually going the same amount on each side. Of course, because it's the middle 50%. So that's a good thing to notice. The z-scores are symmetric, right? So if it's the middle 50%, it's 25% to the right of the mean and 25% to the left. So they would have the same z-score, just one's positive and one's negative. Okay, so here I wrote it on the paper. 34.6 is the lower one, and 45.4 inches is the higher one, and that's the middle 50%. Okay, so we could say the cutoff scores, or the cutoff values, isn't really a score. Cutoff values for the middle 50% of rainfall, or in rainfall, are 34.6 inches and 45.4 inches. Okay, great. So now you know that if we're given an area, we can find a cutoff score. Or like we were doing before, if we're given some values in a direction, we find the area, right? So those are the opposite operations of each other, or inverse operations. We're switching the input and the output. Okay, great. Well, that's it for the normal distribution, and I'll see you in the next video.